Like, is Emma going to Wunderdog or was she working for you?
I'm not sure. I think she was maybe making a holiday or I think she was 2 days on holiday already maybe, or I'm not sure. I don't remember. Because he was
I have no idea to do this actually. Is it recording? Do you see anything that says it's recording? Oh. Do you want to keep this in document? Okay.
No, she's actually.
Sure. Okay, whatever. It's
I
recording.
think online coding, not on holidays.
Okay, so let's talk about making music with code, because everybody's way more interested in this than contentful for whatever reason. This is what I did for my master's, so I kind of have a background in this stuff. So we're going to talk about who, what, where, when, why, and how. The last how part will be more interactive. Brief overview. We're going to talk about this word called skeuomorphism, which is kind of weird. But once you understand the word, then you basically understand why coding music is sweet. What we're talking about, who's doing code-based music, where you can find it, and we're not going to do a historical background. We could, but we're going to skip over that part. And then finally, we're going to make some music, sound, music stuff, sonic art with Super Collider. So, skeuomorphism. The Wikipedia definition: graphical user interface design to describe interface objects that mimic their real-world counterparts and how they appear and how the user can interact with them. So, for example, on your computer, you have a folder, and in the folder, you have files. It's exactly how the real-world thing would work. Why? It doesn't have to be that way, but skeuomorphism basically says that with each new technology, it's basically able to look like something that exists. People are more comfortable with it, it sells easier. And you see this really strongly in the music industry. We have these analog mixing boards that I'm not sure why physically they needed to be sliders, but they've just basically modeled the digital version of it exactly the same, even though there's no reason. This doesn't even exist. There's all code behind there. This is just an arbitrary interface of going up and down. Does volume actually go up and down? Like in a Y, or is it X, or is it Z, or is it bigger or smaller? Like it's kind of arbitrary. And you see it all over. Piano roll, which punches holes. They literally have a piano roll in DAWs where you can write out all sorts of things. Is it the best interface? I would say no. But it's the one that if you want to make electronic music, you're basically stuck in unless you can code. Hence, one reason why. So what is coding? What does it look like? So you've seen this DAW, you have tracks. For those who haven't used a DAW before, these are like effects. You can kind of see some stuff. You can kind of manipulate using this GUI. And everything always goes left to right for some reason, because sound travels left to right to everybody. I'm not sure why, to be honest. Ableton kind of goes as a top-to-down thing, which is why it's revolutionary, that they give you another axis that you can work on. But really, if you look at the code-based stuff, it's whatever you want, you know. Of course, it will be executed linearly, but this is basically you're defining a synthesizer here. You're not even using it immediately. It doesn't matter how you're defining these variables up top. You can manipulate the signal flow really easily. Like just switching one line of code there, you have to take a plugin and kind of switch it and drop it. I don't even know if you can drag and drop it, they swap. I think then you have to make an empty one, and it's just a lot of dragging. And the interface here is much freer. You can do whatever you want with it. The last thing, why this kind of circle that music is stuck in. So music notation kind of started with Gregorian chant. Sorry, I'm talking about history shit, even though I said I wouldn't talk about history shit. But if you look at Gregorian chant, there's no rhythm in it whatsoever. It's kind of based on syllables. Later on, they added some semblance of rhythm, but it was never the beginning. It was never thought with rhythm. So you have these hip-hop artists who can't read music, and people are like, oh, so still sad they can't read music. The rhythmic notation and the type of intricate rhythms that you can do with music just isn't very well represented with modern Western notation. So this circle is actually what I built for my master's, was based on these modern rhythm techniques where they actually write out rhythm in a circle instead of in a line. So if you think about it, 1, 2, 3, 4, 1, 2, it's kind of like the 1 is the most important. So if you were to imagine, you have the top, so like 1, 2, 3, 1, 2, 2, 3. And this is actually a tristolo, it's a Latin rhythm split. 1. That's how you read it. And you get cool things like shadow rhythms, which like if you rotate it, you can see these things. That's super impossible to do with Western notation. And that's why most classical music doesn't utilize a lot of rhythmic things, because it's really difficult to do it. So basically we're talking about ethnocentrism. Lots of music is just white. And even DAWs continue to promote this way of thinking about music in a way that is supposed to be more representative of a certain type of music. From a psychological perspective, sound does not go from left to right. Volume does not go from down to up. Loudness is perceived differently than it's drawn, I think. So who gives a shit? Why does it matter? I'm sorry for putting in a GIF. It was inappropriate, and it will never happen again.
What?
You told me about putting in GIFs or GIFs.
No, it's okay.
Either GIFs or GIFs.
I just read it as a rule of thumb in someone else's rules for presentations. Like, don't edit. Don't edit.
So live coding has been like happening more and more. And again, for my master's, I had to do some digital philosophy stuff. And this guy, Negroponte from MIT, always kept coming up. And this line, he wrote a whole book called Being Digital, which is actually really short. And it's kind of silly that he even wrote it down, because you should read a blog post about it now. Being digital allows the process, not just the product, to be conveyed. I think the rest of that quote doesn't actually help. But it's this change in our view of technology where we're more process-oriented than product-oriented. This is what he hypothesized would happen in the early 90s, and we kind of see it everywhere. Nobody wants to eat food unless they know where it came from, making sure farmers are paid well. We want the earth to be sustainable. We care about the process much more. And even in software now, microservices versus silo. Nobody wants a black box solution. People nowadays want to see all the parts and really need to pick and choose and how these things are flying around. Take it or leave it, it's certainly something that being digital is going to increase. Okay, and then the last part. There's just a lot more that you can do. Things that you can't do. Fucking Uber ads. Things that you can do in the digital domain that you just can't do in the analog domain. So this is a guy, early 1900s, late 1800s. If you really think about it, the player piano was one of the first, maybe the first instrument where you could play things that you could make music that a human couldn't play, which is kind of the freeing thing of a computer, because all of a sudden the sonic possibilities are there that aren't there if you're limited with a dude on a violin. So this is one of his pieces. He would handwrite piano scrolls. So just an example. Julian likes this guy. It was really slow at the beginning. Gradually transitions. And slightly faster. Actually. And
Also sounds great.
yeah, sounds good. Yeah, that's something that, yeah.
35 people don't have a taste in music.
Yeah, it's true. 5,000. I'll keep using examples.
What, you can play that?
No.
Okay.
Unless you are an alien with, let's say, 20 tentacles.
Yeah.
So this is another example of that. There's a whole school called Black MIDI, where the point is to paint the whole screen with just notes everywhere. Originally the goal is to get the computer to break because you're putting so much data in, but our computers are too fast, they can process everything.
But the ME protocol is still slow as fuck. It's a serial protocol.
But there's all these coping mechanisms. It's like skipping CDs. They like fix that, which sucks because the sound of skipping CD was kind of cool, and now it just doesn't exist. Anyway, this is an example of Black MIDI.
You could really draw nice things.
That's what he's working on. So sorry, each one of these is a note on a different channel. The colors are the channels. So this is somebody playing literally all of the notes on one channel, just to give you some perspective.
There's actually a melody you can recognize.
Sure.
Yeah, there is a melody.
But we have to talk about this notion of good, because it actually comes back to skeuomorphism. Like, this is something that was really difficult for you to accept. But if you really think about it, the things that you like and that you find good are things that you're familiar with. And of course, this is a totally new medium. It's going to sound alien. If you want something that sounds familiar, then you try to program a clarinet sound on a computer. But that kind of, you're insulting a computer in some ways, because it can do so much more than just imitate an acoustic instrument.
Not to differ from the topic, but actually companies do that with rumors when they leak a design of something. If it looks different, when they leak it, they get people familiarized with it early, so that once it comes out, people are not shocked and they are really familiarized with it and they don't think it looks bad or anything.
You just take the first shitstorm and think, yeah.
But that's just the leak, so and everything afterwards is not so bad.
Yeah.
Google just did that like 2 weeks ago with their
And
Pixel
then
4.
With this ugly
Yeah.
scrap
They leaked it basically. They not just announced it.
Yeah, I have a friendly blogger writing some nice stuff about it. Bang.
Yeah. The Black. How that goes. It's pretty cool. But we can just follow the slide, post it on that. Okay, so then there's some more complicated stuff. This is actually acoustic, but this is computer-aided composition. So you'll hear a bunch of violins, mainly playing pizzicato. So Xenakis was an architect, and he wanted to make he wanted to use modern science. Like at the time was like statistical gas models. So he basically applied that, and you'll see the score, what it looks like, and you'll hear.
Different.
I mean, that stuff is really, he was in the time of punch cards. I'm going to talk about Xenakis later because in Super Collider, I had to read one of his books, and at the end of the book, he's like, oh, when modern computers are fast enough, I hypothesize that this process will be much easier to do, and I won't have to use all these goddamn punch cards. And in Super Collider, there's 3 generators, just unit generators, like one line of code you can do what it took him like 10 years to accomplish. And then, there's AI, but this is a precursor to AI. Markov chains, does everybody know what Markov chains are? You can say no, it's okay if you don't.
No.
So it's like a decision tree. Like, you have one input, and then it's like 50% of the time you want to go to this step, or 50% of the time you go to this other step. And then those steps will be like 50% of the time you go to this. So you basically feed it all of these notes, and you say, okay, every time that this note is played, it creates a model of percent-wise, this other note will be played, or this note, and then it generates basically based on the style. So we're feeding it a bunch of Chopin, or a Chopin concerto, and they're saying based on how this concerto was composed, write me something else that uses these. It's not quite AI.
No, it's a Markov chain, but it's a pre-AI version, so it already has some coefficients afterwards, and they are
Much simpler.
it's based on the stuff that was in the Chopin playing.
It's only one composition, it's not like a corpus. It should be more, I think. This is just an example of some random Python software. Like, there's tons of scripts out there where you can do this stuff. And then there's also some techniques that you just clean up. can't do in analog. So digital audio goes about average 44,100 times a second. You can sample up or sample down, but you can't really cut up a piece of analog tape or even a digital signal flow. You can't do sample level manipulations efficiently. It would take you like a year to do like a 10 seconds. So there's a granulation is a great example of something that's only possible in digital. You'll see that grain size is how large you're going to sample, and these samples kind of vary. They randomly pick places in the audio sample. You get this kind of eerie sound, eerie, that you can kind of make the pitches random when they get copied. It's like a really complicated delay, basically. So you'll see this dry wet knob. When it goes up, then you'll hear the effect. Usually we use it like it's not 100%.
Still quite human.
Yeah.
That can play probably in a very unhuman way.
Yeah, that's I picked this example because it kind of uses it tastefully. You can make it fucking insane, for sure. Vary everything and then it just, yeah, it's crazy. But if you guys want to get more into AI, Google has TensorFlow, and in TensorFlow there's a dedicated art music AI system called Magenta. So they're always doing cool stuff.
What does the telecom says about it?
Telecom?
Telecom?
What's telecom?
Telecom, German telecom.
They have a
Magenta,
magenta.
they are magenta. That's their color. They reserved it.
It's magenta TensorFlow.
Maybe
that's why it's not so big in Germany.
See a big lawsuit coming in.
Actually, Google also has a pretty good.
Okay.
So
Guys, nobody can copyright the goddamn color. It's a color. It's like copyrighting red.
The Germans do.
Yeah, they did.
Tells you everything about Germany you have to know.
Yeah, pretty much.
Yeah, it's like the Americans trademark or patent for books.
actually, I'm not even sure if Apple copyrighted Apple thing because it's a very generic word.
Yeah, whatever. It's all Java, and that whole court case nobody paid attention to. But anyway, so who does this IRL? Algo ravers. Anybody been to an algo rave? No. It's just like a. You've been to an algo rave?
Yeah, it's possible.
Yeah, algo rave.
Private, something.
Nice, have a good weekend. Yeah, so algo raves are like a normal rave, but somebody's composing on the spot. You see in the background, this is just a photo from a group in Detroit. It's definitely super clever.
So, but basically it's the same like we rave in Berlin for the last 20 years because there are always dudes with a laptop.
Yeah,
It's
but
always
they're coding
unclear.
the stuff.
It's unclear what they're doing. Like
Yes,
this
it's unclear what they're
the
doing.
one this actually has the code in the background. You're watching the live
There was
code.
one in the Seabase when they did that.
So like you can see like, okay, this is gonna play something, then we're gonna bind this instrument called Robo1, and we're passing these note values in, and now it's ending up, we're ending on the snare. Like it's just another like really there's too many DJs who just like push a button and then maybe they touch stuff, but who knows if it actually does anything. You really can't fake this.
Actually, it's one step to prove that you are actually doing something on your laptop by sitting there and
Just
Like,
gaming.
Yeah,
I prepared everything for it, and now you're just gaming.
but this is again, it's focusing on the process. Like, who knows how long or if it really will be popular, but if digital trends continue, people will get sick of having perfectly done tracks. People want to see the tracks. They want the tools that you made the tracks with.
Don't mock my glass. Armin van Buuren for life. Or something.
Exactly. Another application is sound design. A lot of people don't know that there's tons of sound design in every single video that you see. There's some dude backstage at every door that opens, the guy's got to open the door and record it. But there's some things that you can't really record in isolation like this. For example, bird calls. Birds are actually social beings, and they don't sing the same in captivity as they do in the wild. It's very difficult to capture them. You'd have to put a microphone on a tree and just pray to God that a bird comes and there's no wind and that it's perfect. But it's a good, I actually started a tiny library translating some code into Super Collider that I'll show later about how to produce bird sounds. Because it's certainly one good application of Super Collider's advanced features. Yeah, and I posted a link of some more sound design stuff and then bird specific because I'm kind of into birds. So yeah, composers also use coding. People who want to push the boundaries of Black MIDI that we saw earlier, good luck doing that by hand. This Xenakis guy who I showed the crazy composition, this is actually a building he created. It has 100 speakers in it, something like 150 lights in it, just for one composition. Like, he built this whole building for a music composition.
That's in Belgium, right? It's this pavilion they created for the World Expo or something.
Yep.
My professor at the university was making a simulation system that you could hear this sound inside the pavilion and on a wave field system, and it actually sounded horrible. They screwed it completely up. I noticed from my studies I saw this pavilion so often, and they always kind of boiled it down to horrible sound design inside, and
That's like, I don't know, I really want
but
to.
it was in the 70s, so.
All the cool stuff was in the 70s. And
This MIDI stuff, I would totally use it for making graphics and
Yeah, do it.
still try to make it sound so like good, you know? Maybe tell a story and have the music at the same time or something like this.
It's so cool. Actually, there's this FX Twin song, and at the end of the FX Twin song, there's some very harsh and unharmonic sound.
Yes.
And it turns out he used his face and put it into a program that calculates graphics into notes, tones, and use those tones in the track. And if you look at it in an FFT analyzer, you will see his face at the end at the notes, and this
guy
really
is awesome.
That
sounds horrible. I know it's song there.
So we could talk about online stuff, and there certainly is a lot of cool stuff. I definitely recommend Web Audio Weekly if you guys are interested in web audio. Just look at the backlogs, but it's not really weekly, every like couple weeks or a month we post a new thing. Tone.js is great, super stable, and a lot of people build stuff on top of Tone. Klangmeister, but also, I like Glitch.
Which sounds also good.
This is just like really in the browser, but the notation is pretty similar to Super Collider. This is now Glitch doing the drums, and we got the chords, or solo thing.
Probably all the lines. It's only that.
Yeah, but that's easy because the song is easy and the song structure is kind of easy. You don't have to use that a lot.
It's not a thing of difficulty or easiness.
Oh yeah.
That's not tough the model.
But if you look at this is 34 lines of code.
John's nice.
Who knows how many hours or days or months it took of practicing for those guys to create this. It's just showing the expressive power.
But they introduce a complete new syntax and all stuff.
What, these guys?
Yeah.
I mean, every single programming language has slightly different syntaxes, just like normal programming languages.
So Glitch is more programming language.
Is it JavaScript with like lots of extra functions, or is it its own?
I think that it might be based on JavaScript.
Click on the bar. Click on the just. Click
Oh,
on
yeah,
the
This blue bar there.
The blue bar.
The blue bar.
Blue bar.
Can you go back?
In GitHub.
I was just kidding, it's a test. This one?
No.
Yeah, it doesn't look clickable on it.
Let's go.
Go and see. Let's look.
Yeah, you're good. We're just making weird noises.
It's written in Go. That's
Yes,
why it
go.
looked so Go-ish.
Go will add to the list.
Doesn't look broken.
Yeah, if you haven't seen Berlin, you can go to these places. I'm just going to focus on SuperClider. Again, tons of different languages you can do. SuperClider is awesome because it's totally community driven. It's built on C++. There's tons of UGens and extensions. The documentation is amazing, actually. They have a special pattern library that's specifically for music. And it sounds really good. Like the audio processing really makes good use of the computer sound card. I can't really describe it any other way than that. I'll show you later. The other thing that's special about SuperClider is the architecture. It splits the client from the server, and it's very firmly split. The server, the synthesis happens in something called SC synth, and you speak to it in SC line. The result of that is you don't even have to be on the same computer to control it. You can send signals over a network, and I guess we learned that glitches are going to go. Lots of people have maintained libraries that are basically on top of the client. So I met the guy who is a contributor to Overtone in Berlin. Foxdot is written in Python, Tidal is written in Haskell, there's SuperClider JS if you want to use Node. It's whatever you want, really. And the server is really what is the sound that's so cool. The one thing to notice is that most of these things are functional languages, just because it's, especially in live coding, it's much more enjoyable to watch people write in functional languages where it's expressive. You have a good function name, you kind of know, you see the arguments being passed into a function, and you can see what's happening. In addition to other functional awesome things. Right, so let's load some shit up.
Okay, turn your volume down.
Yes.
But basically it splits between data and audio, like in maximum speed.
So maximum speed doesn't do this split. You can split the audio engine is kind of in the patch. This is really, you'll see in like 2 seconds. It's like a separate application is running the audio as opposed to the control.
Okay, that's why client server.
Yeah. So we'll boot up the server now, and it's like, fuck you. Yeah, could not initialize.
Number of devices is 5.
Let's try it again.
The smash sample rate.
The output sample rate needs to be adjusted. Wait.
I don't think it's this. I think it's the speaker has to be adjusted.
Yeah, but I think you can adjust this on here.
I've never seen it. We can really just use my computer speakers. Like it sounds really good through the computer speakers. All right, using computer speakers.
Interesting. Hard-coded 48,000.
Okay. So we've initialized the server. You can see this kind of SC synth has been created for us in the background. So let's just make some basic noise. So a sine wave is kind of the basic thing you can do. You see, just start typing. Yair's asking me what the best IDE for SuperClider is. Definitely to start, this is amazing, because then you just push Control D on it, and you load the documentation for it. This is, if you just download this from GitHub, it comes with this IDE. So, really great documentation, and you see, you can just copy and paste it. So this is going to load a sine oscillator at 200 hertz, 0 phase. Sometimes phase is important for stuff, and at half the volume. The thing to notice, we'll talk about that later. Let's hear it.
Maybe higher the frequency.
Yeah, let's raise the frequency.
I think
this is 500.
Let's not raise it.
Let's
not raise it more.
Yeah,
So
those have a dog.
you see that each time I'm calling this, it's actually creating an instance. It's sending it to the server, and it's running on the server. So this means that if I want to change something, like put another one in there. Each time,
10,000.
Yeah, no, you can. You can easily like blow up a server. This is one of
Please
the.
don't.
We won't. But it's a difference in architecture. If this was JavaScript and you're reevaluating the function again, you fucked. Like if you stopped the audio thread, you would have to immediately extract, make a proxy and do it that way. You can definitely do proxies in SuperCloud also, but it's from the beginning split client versus server. You can't really mess with the server that much, and that's by design. Another thing to talk about: control rate versus audio rate. This is one of those things that'll get you mixed up. You can do basically any function, you can do at a control rate, which is just not 44,000 times 100, 44,000 times a second. It's slower, but you don't need it to be that fast. So the default is 1 second for a control rate. So this is the same thing, but it's going to go from 2,000 hertz to 200 hertz. Again, 0 phase and at half volume. And then it just stays there. And we see that actually you can totally change this to audio rate, no problem. It does the same thing, because sending more isn't going to make anything bad. But imagine you have, 1,000 instances of them. It's going to start to crap out if everything's going in audio rate. Sometimes you want things at a control rate and not an audio rate. Yeah. So this is just the introduction example, the first thing we talked about. Yeah, it's kind of tricky sometimes. You have this emergency kill switch to just immediately stop the server, which is important sometimes. And it's always important, I often forget, to boot the server, because if you try to do this without booting the server, it's like, I don't know what you're talking about. You didn't start the server, because again, the client and server have to be split. So you always have to boot the server. And then it's like, okay, let's do this. Yes.
This is a similar sound in Dublin, and so when you press the thingy at the pedestrian way, the traffic light,
Yeah.
pedestrian traffic light. You press it and then the doop, 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 pew, beep, 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 beep. And they always shoot someone with the alien gun.
Just to tell you that it switched from red to green, or?
Yeah.
Okay, nice.
But it's not everywhere.
That's acoustical workflow like the traffic light.
I mean, they anyways have this tuk 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 tuk. That's enough, and it's also in other parts of Ireland enough. But in some parts they have this pew in the middle. I don't know.
Maybe the tuk tuk wasn't enough anymore.
Yeah. So we've seen how to make a synth. To control a synth, they have this kind of intricate. You bind these events. So we see here. We're setting p to this p-bind function, and we're passing in 2 arrays using this p sequence. P is the pattern library that they use. And we're creating a stream. And so we can consume this stream. Let's imagine we have a clock that's ticking, and each beat we want to get more data out. So we can do this manually. See, the first thing, we have degree 0, duration 0.5. Yeah, it's the same, and the next one's 4 and 0.5. And this is basically the main way that you can get data out good data out continuously. This one is do it once, but of course you can change it to 10 or however long you want. It evaluates, then it just goes on now 10 times. And you pass this data onto a synth, or whatever you want to control. It's pretty straight ahead. So let's say we don't want to manually enter these things. There's also a lot of great little ways to dynamically create them. Like for a series, you start from 10. So it says, give me 5 things, starting at 10, going from 2, adding 2 each time. So if we wanted to add, 100 each time, you get out 100 each time. It's really useful if you're going to work on harmonics. Geometric, I think, is multiply. So give me 5 starting at 1 and multiply by 3 each time. Fibonacci sequence. Algorithmic composers love Fibonacci. You can do it starting on different numbers. This is super useful. You have an array and you want to get back a random member of that array, but you don't want it to be truly random. You want some to happen more often than others. So this is a weighted choose, where the 1 will happen only 10%, the 2 will happen 20, and etc. So this way you can kind of have more control over what comes out. 64 kind of happens, not so much more.
It's pretty nice.
It's some stuff like that, where you can do it in JavaScript, or it just comes pre-built in this library.
Actually, with a lot of Lodash.
Yeah, there's a Lodash definitely helps with these things, but like just filling an array as Fibonacci as default. L systems, we'll get into, we can show some L systems and stuff, some more complicated things. Okay, so we've now seen how this thing works. So before we evaluate it, you see we have this rhythm, event, proxy. We've seen this notation before, and now we have a melody also with degrees.
This, is it a tilde?
Yeah, so the tilde, I guess I learned it from Lisp. It's a global variable, which of course is dirty, you should never use, but
Don't ever use it. Okay.
real life coding. Yeah. So we're doing this like line by line evaluating, which is why, like, kind of why you need it to stay in the memory. So now rhythm is in memory, I guess, on the stack.
Depends.
Yeah.
It's a kill, it depends.
Now we have a melody on there. We're going to chain them together using pchain, which is a nice function. So it's just generating stuff. And what's interesting is you can change variables dynamically. So we're going to change this to a different synth, pass in some different variables. When you hear there's no audio stoppage, we just sent the signal to the server, hey, switch the thing, switch the melody. The rhythm doesn't change, it's still the same. And it's just this kind of way that you can control things independent of each other. Makes it super flexible to use. Again, yes, you could do that in JavaScript, but it would certainly be many more lines of code and lots of stuff in the background. Which we can get to in the superclimber also. Okay, so I'll do a demo of this bird project that I've been working on because I built it, so I know how it works. Bird songs. My wife said that the warbler, oriole, and casting bird are the coolest. So let's do the warbler.
Yeah.
I guess it's W. Wait, where are you?
Yeah, can I bird?
Okay, so this one is pretty big, but this is because it's based on, it's basically based on spectrograph data. So you're taking the overtones. You guys know that, I guess I'll give you a brief music physics. The power of each overtone kind of determines timbre. So even if Omar is singing the same note as me, the power of the overtones in our voices will either be ordered differently or will have different energies. And that's why the timbre is different when we're just holding a note. At the beginning of notes, you have this like kind of noisiness, which also can be instinctual. But when you're actually holding the note, it's the power of the overtones and the way that they're layered that really creates the sound. So you can just basically recreate the spectrograph and you get a very good representation of the timbre of the sound, which is basically what I stole this from a guy named Bill, who built this basically in common Lisp music, which is annoying. Nobody wants to write Lisp. Sorry, Mr. Edwards, he's my professor. So we basically see these are envelope generators where we're going from 0 to 0, we're starting at 0.6, and then we're going to 1 in 0.5 seconds. This is kind of how the rhythms, the kind of shape are created by these parts. And then we have this synthesizer, which will take these, create a task, which says like, yeah, let me load it. So we're creating a task, basically this bird now, we're creating a bird. And when we play this bird, it will go through these tasks, it'll wait till they're done, and it'll go to the next one once it's done. And yeah, so let me just play it. Yeah, that's basically it. Kind of a lot of code, but this is all that you need to do
Is
that.
this from scratch?
No, I basically I just wrote out what this guy named Bill Schrock, I never pronounced his last name, did earlier, and I just rebuilt it in SuperCollider. But he built his stuff with analyzing these spectrographs. If you want to do something like this, all you have to do is find the spectrograph of the sound you want to recreate, get the levels, and then do it. And you will get data structures like this. These are all compiling from the synthesizer that's running all of these. Yeah, this takes the values and runs through them more or less, and then finishes them. Yeah, these are just helper functions. This is the good stuff. And then I'm partial to the Baltimore Oriole, of course, because that's where I come from. It's our state bird. All right. Right. Okay. So anyway, this is an example of sound design. It's kind of an ongoing project that I want to. There's 50 of these that he did. I want to start with those. Eventually, kind of make soundscapes together where maybe you have some wind and there's some birds that are farther away. Maybe there's a fat bird who's hanging out with this little skinny friend, and kind of making all these instances, classes of birds, and passing in different variables. It's a work in progress. But just as an example of sound design, what's possible. Yeah, it's not just animal noises. You can also do whatever, inanimate objects as well, like a bubble. So we have this, 11 lines of code to kind of record the bubble. It'd be annoying. You gotta stand over. Like, you gotta think about a guy whose job is to record a bubble. It's annoying. But now we can just record. Bubble. That's cool, we got a bubble, but of course bubbles rarely happen by themselves. But luckily we got all this cool sequencing things.
Bubbles lab.
Yeah, hold that. So we kind of find it. Again, we can kind of set out whatever you want. So you can see how you can make things explode really fast. But that's super easy. That took what, like 2 seconds to make? Way easier than like boiling some water and waiting for holding the microphone.
Was that bubble map basically like you started playing and getting parallel?
As you can send as many instances, if you look at the server calls,
Yeah. Given
you're creating a synth. I guess we already did that. Yeah, so this event stream. So this late thing is when it fucks up, it tells you, oh shit, I missed that by like 0.08 seconds or milliseconds. Milliseconds. And if you do enough, like lots of stuff will start happening late. Or not. So SuperCollider, super expressive. And now some sound design.
Yeah, for Snyder, fine. Yeah. She's fine.
There's a lot of stuff. There's a trend to do SuperCollider tweaks. So this is in 140 characters, what you can do with SuperCollider. There's a lot of these online. That one sounded cooler in my head.
That's not too bad. Yeah.
That sounds like what tech code basically. that is great what tech code basically.
You're probably in.
But nice, it's
Yeah, you just go on Twitter and you like look for these hashtags. You'll find lots of them. It was like super cool like 5 years ago, but they're still floating around.
so
This is the Gendi. So this demo, this one shows introduction to using the mouse to control stuff. We were talking about maybe bringing in a keyboard, and of course you can do that also with SuperCollider. That's super easy for any variable. You just say mouse X, the control rate. When you're over here, give me 10, and when you're over here, give me 700. So depending on what you feed it, it can be cool. So now, like, instead of just doing one thing, and it's super nice to like create things with.
That's pretty nice. You could just have boxes that catch the mouse for different slots and then just move the mouse randomly or something.
Also, sounds like a virtual therapy or something.
Yeah. Yeah. You definitely built there with like 2 lines of code. Well, I guess, yeah. Okay, so if you want to keep extending stuff, there's these libraries called quarks, which these next few examples will be using quarks. They're basically just super collider code that somebody else wrote and live online. This is an example of a fat beat, because some people just want to make fat beats. Basically loading some 808 samples, and then setting the tempo. We got some bass, kicks, drums, and we're just doing it. And of course, you can do all these things statically. Like, you don't have to do live coding to do cool stuff. But you've seen now, like, this is super easy to do. You just create a pattern, some rest patterns. But the live coding is what we came for.
Super easy.
This is like the greatest tutorial ever. I found this yesterday and was like, damn it, I don't think I can teach any more than what's in this tutorial. So I just put it into, I made a GitHub sub module in my repo with their module in it. Just really great examples. Let's do some techniques for modifying those. So it has this setup file that you always have to call the setup file, which basically boots the server if it's not booted. It gives you this little GUI, which I guess we can keep open. I don't know, because it'll get hidden. It's nice, you get this. You can make GUIs on Super Collider, like it's not against the rules, there's tools to do it. But of course it's not the strength of it, or you're using it to get away from a GUI, so it'd be silly to limit it. But this is a good one because it has a spectrograph. So you gotta see internet enough or not. Okay, so let's just look at this code real quick. We have the snare, hat, cymbal, T, and then Tom, yeah, could be. This preloading function loads this instrument with this buffer set to this kind of encapsulated buffer that she's made. This is like an example of a live coding environment. You don't want to code everything, you want to code the fun shit. And we're setting these durations to be kind of random with this p-white function. This is one of those random functions that'll give you different things. Everything is going to be amplitude 1, except for the hat, which will kind of randomly switch between 0.2 and 1. And that's basically what you hear. So, I'll turn it down. Turn it down a little bit. So while that's going, of course, you can change stuff. So let's change the kick pattern. Oh, I guess the kick wasn't in, so we're adding the kick now. Now you have a bit more sense of time. And of course, then you can change all the other ones to match the kick. And all of a sudden, the chaos becomes more unified.
Sounds like some super future dance music from England.
Yeah.
Grime, or
Of course,
I would call it grime.
You can go back to making it crazy ass shit. Go back in line. And vary it however you want. Add some effects. You can change the tempo. Set things differently, anything you want. Let's break it down. Vary things at that tempo. So, ideally, the aesthetic is that you kind of like figure out what you're doing and you write these things by hand, like, oh, okay, I want to set the tempo to be slower or faster. But these are just great examples. This is basically what you could do in a real live coding set. Thank you, person who made these.
That is actually kind of
Awesome.
yeah. If I had known that, let's say 15 years before,
This
I
is
would never
I
use
would totally do all this.
I never would have used Reason or Fruity Loops or
These-
stuff like
these
that.
Yeah, exactly.
I don't think these things existed 15 years ago, to be honest.
This?
Yeah.
So we had it in our studies at the university. Everyone who was cool enough was super collider, so it was actually the same, I guess.
Right. Yeah, that's basically like, I can show you like a dozen more examples of how, like these are rhythmic things. You could look at melodic ways that you can organize pitch. Yeah, I didn't even look at this file. Let's check it out. So of course you have to set up shit every time because maybe your tempo changed or some different variables are declared. I have no idea what's going to happen.
It's from 96.
But the class is not defined. I'm sorry.
So
Those
it's
motherfuckers.
very, very old.
What do you see in 96?
96 in Wikipedia is 96.
Okay.
Something in
Character 62.
5? It starts at the bracket, right?
You know, it removes the comments when it interprets it.
Oh,
So
shit.
1, 2, 3,
Thank you very
5.
much.
Character 62.
How do you get the count?
Good.
This is bullshit. I mean, seriously.
What does it say it's not?
Thank you for removing the comments before you check.
Okay. I got no idea.
This is open source, right?
Yeah. You can see
It would
it.
be a good time to change this.
Alright. Damn it. We don't even use this. Oh, that one works.
Boring.
Phasing. So phasing is a technique that lots of minimalists use, where basically you have two things, two patterns that started together, and one slowly gets out of line. It's super difficult to write out notated, because our modern notation uses things in sequence and everything, but code is super easy. It's usually really long. You gotta wait for it to get out of phase.
Maybe your loudspeakers on the Mac aren't so good to hear phase differences.
Maybe I
Yeah,
just don't
now
know.
it's getting a little bit blurry.
Anyway, this will go on for a long time. Yeah, so check out this repo that I put in here. I shared the link in the tech session.
Yeah, I also send a link with all the sessions in general and the files that were in the session. Hopefully, if it was recorded, also the video recorded.
Yeah, we'll let you know in about 30 seconds. Questions?
No.
Actually, that's awesome.
We did it, guys. Let's all drink beers.